All right, so we're going to move on to our last three problems here. Number 18 is first up, and what it is a straightforward system of equations. This is one where you're probably going to want to use elimination on. You could use substitution, but it's set up for elimination. Now, this problem is asking you to solve for x. Now, the way it's set up, it's easy for you to eliminate the x and solve for y. And that's probably done on purpose. You need to make sure you're paying attention to what it is that you're solving for. Now, I'm going to go ahead and solve for x because honestly, once you solve for x, it doesn't take much work to solve for y anyway. We just need to make sure we're keeping track of what the question's asking us to solve for. So I'm going to solve using the elimination method, as I said, and I'm going to subtract these two equations. So I'm going to subtract my x's, and those are going to go away. Here I'm going to have 1y minus 2y is negative 1y, or negative y. And then I have negative 9 minus a negative, so plus 25 is going to equal 16. So when you solve this, you're going to get y equals negative 16. So that's going to be your y value. However, we're looking for the x value here. So I'm going to go x plus y, which is plus 16, negative 16, so minus 16 equals negative 9. So here we're just going to add these together, add 16 to both sides, and x is equal to 7. So that's going to be number 18. Number 19 is dealing with a right triangle. So this one, and you see, anytime you're dealing with geometry or trig or anything like that, you're going to want to draw the triangle that it's describing. So let me go ahead and draw that real quick. So I have a triangle here. They say sine of x is 4/5. Now what you need to do is you need to put an angle in here and call it x. I'm going to call this angle x, and that means the opposite and the hypotenuse are going to be 4 and 5. So I'm going to go 4 and 5. So that actually means this side is 3. As you can see, this triangle is not drawn to scale, but that's okay. So there's my triangle. Now they want the cosine of 90 minus x. Now what you have to realize, and they've actually do this a couple times on the test, is this angle right here, if these two angles add up to 90. So whatever this angle is, this one's always just going to be 90 minus x degrees. So if that's x, that's 90 minus x, because these two, again, add up to 90 degrees. 90 plus 90 would be 180. So we're actually looking at this angle. Now, in this case, they just want the cosine, which is adjacent over hypotenuse. So I don't even need this 3. I mean, it's nice that you have it in case they do, but I want the adjacent over the hypotenuse. So the cosine of 90 minus x, again, that equals adjacent over hypotenuse, which in this case, the adjacent side is 4, hypotenuse is 5. And you're going to get 4/5. Or you can go 0.8 if you wanted to, but that's going to be number 19. Number 20 is giving you a equation where they have two variables, but they're giving you two equations, so it's okay. Now they're asking you to solve for x. So what you're going to do to start with is try to get an equation that's in terms of x, because right now we don't have an equation in terms of x. We have an equation in terms of a, and we have one in terms of a and x. So using a little bit of substitution here, and again, if you have two equations, we're going to want to substitute. I'm going to take this and I'm going to plug it right in here for a. So this is going to be now 2 times 5 radical 2 equals the square root of 2x. So this becomes 10 square root of 2 equals the square root of 2x. And now we need to solve this for x. One thing that you usually want to do in a situation like this is try to eliminate the radical. And there's a couple of ways you can do it here. One way would be to divide by the square root of 2 on both sides. It might be a little bit faster. The other way is just I try to be consistent here in the way that I solve these. I usually will tell you to square both sides, and that would work as well. Even though it makes the numbers a little bit bigger, I like to be consistent in how I solve these problems. So I'm going to square both sides. Now if you square both sides, this becomes 10 squared. So that's 100 times the square root of 2 squared, which is 2. So we end up with 200 on this side. On the right-hand side, we just get the square and the square root cancel, and you just get 2x. So if you're going to solve this, you divide both sides by 2, and x is going to equal 100. So they just wanted, in this case, they wanted x, so we have it, and there we go. So again, as I said, the other way you could have solved this, once you got to this step, you could have divided, you could have thought of this as 10 radical 2 equals the square root of 2 times the square root of x. You could have done it that way. It would have been pretty fast as well. This didn't take very long, but I just want to show you. You could have divided by the square root of 2 on both sides. This would have been 10 equals the square root of x. And then if you squared both sides, you would get 100 yet again. So it doesn't really matter which way you go at it. Again, I tend to always tell you square both sides, try to get rid of the radical that way, but sometimes there are other methods you can do. So anyway, that's going to be number 20, and that is section 3 of test 1.